In finding cube roots and higher, we're going to go through the same process as we would for square roots. We're going to try to look for a number that is a repeated factor, however many times the index says. So the index says 4. So to find the fourth root of 16, we're really looking for one number that is repeated as a factor a total of 4 times to equal 16. And we should be aware that that number is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. The way that we evaluate that is we take that number 2 and we raise it to the power of the index. 2 times 2 is 4, times 2 is 8, times 2 is 16. That was the original radicand, so I know that I am correct. The cube root of negative 27, the index of 3 tells you that you need a repeated factor that occurs a total of 3 times. If we're repeating that factor and we're getting a negative result, that factor is going to be negative. 27 is a perfect cube, that is 3 times 3 times 3. So the cube root of negative 27 would be negative 3. The way we can check that is by taking that cube root. Since it's a negative, I'll put it in parentheses, and we raise it to the power of the index. Negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is positive 9. Positive 9 times negative 3 is negative 27. That was the original radicand, so I know I am correct. Last one here. Negative the fourth root of 81 over 625. I'm going to break things up a little bit. I'm going to break this up because this is a root of a quotient. That's the same as the quotient of the roots. And I'm going to move the negative to the numerator. So I'm going to be looking at the fourth root of 81, and I'm going to make it negative, over the fourth root of 625. So again, I had a root of a quotient, so a root symbol over division, and then that was equal to dividing the root symbols of both the numerator and the denominator. And like I usually do, I will keep the negative with the numerator. So now I'm looking for a negative of some number that is a repeated factor 4 times to equal 81. I know that 81 is 9 times 9, and I know that 9 is 3 times 3, so I know that 3 times 3, which is 9, times 3 times 3, which is 9, will equal 9 times 9, or 81. So I know that the fourth root of 81 is 3, so the negative fourth root of 81 would be negative 3. Here, the fourth root of 625, so I'm looking for one number that is the product of one number 4 times that equals 625. Well, it ends in a 5, so the first number I'm thinking of is 5. 5 times 5 is 25, times 5 is 125, times 5 again is 625. So the fourth root of 625 is 5. Therefore, the negative fourth root of 81 625ths equals negative 3/5. The way we check that is we take our result and we will raise it to the power of the index. So I'm going to take negative 3/5 times negative 3/5 times negative 3/5 times negative 3/5. So I took my answer and I raised it to the power of the index. Negative 3 times negative 3 is positive 9. Times negative 3 is negative 27. Times negative 3 is positive 81. Is that correct? Negative times negative is positive. Positive times negative is negative. Negative times negative is positive. So why is that giving me 81? That's giving me positive 81. Oh, right, because that's underneath there. And then under here we have 5 times 5 is 25, times 5 is 125, times 5 is 625. Again, this is always going to give me the number underneath the radicand, which it is, which is 81, 625, and the reason that this is negative is because the negative is outside. So we know that we're in good shape here, and all of these are correct.